So we're going to end this lesson talking about word problem tips. There's a few tips you want to do, and then we're going to work harder word problems. And there are some of these in the homework. So word problem tips. Usually start with what has one unit. So if you get to a problem and it's got all these pers, like grams per hour and, miles per second, those are never things that you start with. You start with something that has just a G, just an L, just an M. That's the number you start with. That's something people have a hard time with, is knowing where to start. Start with a thing that has one unit, not lots of units. You don't want to start with something that has a comparison, like this many grams equals this many hours. That is what you use to help you get between units. The single units are what you want to start with. Here's some other tips and way things can be hidden in word problems. If you hear Tammy travels 100 miles per hour, what that means is you can write it like this, or it means that 100 miles is equal to 1 hour. So when you're filling out your factor label, it means in 1 hour she went 100 miles. Another tip. Sometimes you'll see one night I only got 5 hours of sleep. Sometimes the numbers will be written as words. 1 night equals 5 hours of sleep, or 1 night per 5 hours, or 5 hours per night. These are all conversions they use in the middle of the problem. Even though this number looks like it's alone, 1 night I only got 5 hours of sleep. You know it's not alone because there's like 2 alone things in the problem if that's the case. So those 2 numbers are tied together. Here's another one. A pill contains 500 milligrams. That means 1 pill, see, we put it in a number context, or 1 pill per 500, or 500 milligrams per 1 pill. All right, and this last tip here. If you're asked for a certain measurement over another measurement, we had 2 of these at the end of each section. You're going to start with the number that goes with the first type of measurement as on top, and the number with the second on bottom. So distance over time. If some problem asks you to give you what is the distance per time or the distance over time, the unit that they are telling you they want distance over time, you pick the unit that is a distance unit that goes on top and the time unit on bottom. For example, maybe it'd be a meter or a mile. Those are distance units, and then seconds or hours are on bottom. And that's how you know how to put those together. So let's try a few harder problems. The first one is a nonsense problem designed to see if you understand how factor label works. So, how many gar-gars will fit in a crate? So, what we want to know is gar-gars. What we start with, we'll look over here. It says a crate holds that many udels. Each udel has that many arbots. That many arbots are many carcos, and each carcos holds 4 gar-gars. This designed this way to remind you that rule or that suggestion about the number 1. A crate holds 100 udels. 1 crate equals 600 udels. See, a crate, that's the same thing as saying 1. Each udel, again, that is 1 udel, is 10 arbots. 2 arbots will contain 1 carcos. And then each carcos, again, 1 carcos equals 4 gar-gars. Again, this is the idea behind this. It's just to help you see the relationships by kind of using nonsense words. So how do you know where to start? All of the things I've underlined are pairs of units. And there's no numbers, right? Or is there? You're going to know how many will fit in a crate. Now, isn't that tricky? You're going to start with a crate, which is 1 crate. Go ahead on your own. Use all those conversions up in this section and get it to a gar-gar. I'm going to go ahead and help you start the second one. And you're going to work these problems on your own. Solve density like unit conversion. So first of all, yes, I know that you now know density is mass per volume. I know you know that, and you can work that way. We're going to use density as a unit conversion problem so that you can see it can be used like that. And so that you have an example of it. So instead of like trying to use this formula, don't use this formula when you're solving this problem. Use the density, and you're going to see it in a minute. See, here's the density. You're going to use that as a unit conversion. So let's read this. I suspect a gas station is watering down their gas. I took a scale with me and measured out 1 gallon of gasoline. A gallon is a volume. If you didn't know, that's a volume. The mass was this, 7 pounds. And by the way, here's your relationship. First question, what is the density of the gas at the gas station? Okay, yes, you can do density equals mass over volume, but I want to show you how to do it in a different way. Actually, I'm going to show you on part C. I just realized. I'm going to show you on part C. But if it tells us that it just wants to know the density in grams per milliliter, that's what I'm going to do. Is I'm going to do grams on top, and I'm going to do milliliters on bottom. That's what my question mark is. Over here, I have a gallon, which I know is a volume, so that means that gallons are what I'm starting with on bottom. And a gram is a mass, so somehow I'm going to have to get grams from pounds. This is what I start with on part A. And what I'm trying to get it to is grams per milliliter. So I'm going to go, I automatically put that down diagonal like that. And then I go ahead and I convert it. I look up there because I know I need that pounds. I need that to be a different value. Where is it? Oh, wait a second. It was up here in some of these other problems. All right, so here it is, a pound. A pound is equal to 453.59 grams. So you can go back and put that number in. Oops. So notice I've gotten from pounds, I've gotten rid of that. And I'm at my grams, so I'm good on top. Now I got to get my bottom part figured out. Again, pretend that this isn't there. Imagine it's not there. So I'm going to go from gallons on top to either milliliters or liters. So I might go up and look again. Does a gallon go to a milliliter or a liter? Let's see. Oh, here we go. It's a liter. So I'm going to get it up to a liter. And this happened to be a liter conversion over here too. And I'm going to go from a liter to a milliliter. So again, gallon, gallon. Notice these diagonals. This is where my units will be canceling. And then this is where you're going to fill in. And then the last part, once you have this number, you're going to compare it to this one. This is the number that you're comparing it to. And you're going to decide if the gas is watered down or not. You don't actually have to work the first part because I want this to be thought of as a factor label problem, not a straight up density problem. Just so that you can see different ways it can be used. If you want to solve it density-wise and you want to change all the units around, after you can do that too. So do those two problems on your own. Don't forget to do the part about the crate. And then don't forget you've got the student learning example indicators just to go back and look through your notes and make sure you're comfortable with the factor label method. It is not going away. Ask me if you have questions.